Hi guys. We are in section 11.7 looking at adding and subtracting now when we have different denominators. So we're going to put into practice what we did in 11.6, finding the least common denominator so that we can do our adding and subtracting. So we're going to start out again with a simpler problem where our denominators are just numbers, and hopefully these ones we can look at and see what we need to do. We have 15 and 3 and 5. 15, sorry, my itches. 15 has 3 as a factor and 5 as a factor. So that means that 15 can be my common denominator. So I'm going to rewrite my problem, leaving this one the same because it's staying the same. And then I'm going to change this so that it has a denominator of 15. So that's 5x over 15. And then I'm going to change this one so it has a denominator of 15. So I'm going to multiply it by 3 over 3. Remember, I'm just multiplying by 1. My 1 just looks different. So that gives me 9x over 15. So then I can add those together. 2x plus 5x is 7x. And 7x plus 9x is 16x over 15. And we're done. And because there was nothing in the denominator that was canceled or anything like that, I don't have anything to exclude. Because we still have to do that when we cancel factors that have variables. We have to figure out what excluded factors there are. But this one we don't have to worry about that because there are no variables in the denominator. Okay, so now let's look at B. So I have 3 over x plus 1 plus 2 over x minus 3. So my common denominator needs to have x minus 1, x plus 1, and x minus 3. That's going to be my common denominator because x plus 1 goes into x plus 1 times x minus 3, and x minus 3 will go into x plus 1 times x minus 3. These are factored, and remember we pick the largest amount that any factor shows up. So x plus 1 shows up once, and x minus 3 shows up once. So I multiply those together to get my least common denominator. Okay, and you can write that out like we did before. This one, though, we didn't have to do any factoring on. So we just know that we have to use both of those. It would be like if I was adding 1/2 and 1/3. I can't factor 2 and 3. I'm just going to make my common denominator 6. And 2 goes into 6 3 times, so I have to multiply by 3. And 3 goes into 6 twice, so I have to multiply by 2 over 2. So I just have to multiply the one using the other, and vice versa. So this one, I will multiply times x minus 3 over x minus 3. No plus sign there. And this one, I'm going to multiply by x plus 1 over x plus 1. So that will give me my common denominator. And I'm just multiplying by 1, remember? So 3 times x minus 3, I am going to write that. 3 times x minus 3. And here I have 2 times x plus 1. Okay, but I'm not finished. I'll erase my example here if I can. I'm not finished because I need to simplify this, because the whole point is that you're combining them. So because they're factored here, I can't combine them. So I'm going to factor, or not factor, I'm going to distribute because I need to do that so I can simplify. So I have 3x minus 9. And when I do that, I'm going to put these all together at the same time. Okay, so I have 3x minus 9, and then that's going to be plus 2x plus 2. So I did 2 things in that step. I distributed, and I combined my numerators to have a common denominator. Okay. So when I combine things here, I have 2x or 3x and 2x, which is 5x. And negative 9 plus 2, which is minus 7, over x plus 1 times x minus 3. I can't do anything else with that because I can't factor with the 5 and the 7. There's nothing to factor out. So nothing was canceled. So I don't have to worry about writing any excluded values because somebody looking at it will know I can't have x be negative 1 and I can't have x be positive 3. Otherwise, I have nothing to worry about here because I didn't cancel out anything with a variable in the denominator. So this is my final answer. I am going to rewrite this one. 11.7c. We're going to do 10x plus 8 over x squared minus 1 plus x over x plus 1 plus 3 over x minus 1. This is similar to what we did in 11.6 when we had the y squared minus 1 and the y plus 1 and the y minus 1. This is our common denominator because 10x plus 8 over x squared minus 1. Remember, that's the difference of two squares. So I'm going to write that like that, and that's how I'm going to leave it because this is my common denominator. X plus 1 times x minus 1. So this one, I have to multiply by x minus 1 over x minus 1. Okay? Because that's 1, x minus 1 over x minus 1. And this gives me my common denominator. So I have x times x minus 1 over x plus 1 times x minus 1. And then this one I need to multiply by x plus 1. So I have 3 times x plus 1 over x plus 1 times x minus 1. And this one, when I multiplied here, I just switched these around so that they all match. Okay, you don't want to cancel anything here because we made this. We added this funky 1 in that cancels, but we don't want to cancel it because we want it there. Just like how when, I make my 1/2 be 3/6, I could simplify that 3/6, but I purposefully just did the work so that I had this special number so that I could use it. We'll simplify later. So we're kind of unsimplifying in an effort to put everything together, and then we can see if we can simplify again after that. So leave that be for now, and we're going to combine our numerators because I have a common denominator, and remember the rule of math is I can add my numerators if my denominators are the same. So I have 10x plus 8, and I'm going to distribute these as I go because I want to be able to simplify more later. And so I have to do my distributing. I have to make it look a little bit uglier first so that I can combine things. So that gives me x squared minus x plus 3x plus 1. Technically, these are in parentheses, but because we're adding here, it doesn't matter. It's not going to affect the signs of anything. So they aren't super necessary, but if they make you feel better, that's fine. All right, so now I'm going to combine my like terms and write it in order. So I have an x squared by itself, and then I have 10x minus x and plus 3x. Okay, so that means I have 13x minus 1 is 12x. And then I have, this should be 3. Hopefully you caught that when I did that. 3 times 1 is 3. So now I have 8 plus 3, which is 11. And then in my denominator, I have x plus 1 times x minus 1. Okay. Now, I'm going to try to factor this because there's that part of me that says, hey, this is a math book written for learning, I would guess that there's one of these factors in here so that I could cancel it out. There doesn't have to be, but it's a good thing to try instead of stressing yourself out. Now, both of these are positive, so that makes my life easier because I know that whatever I multiply to get 11, I have to be able to add to get 12. There's only one way to multiply to get 11, x plus 11 times x plus 1. 11 times 1 is 11, and 11 plus 1 is 12. Okay? So then down here I have x plus 1 times x minus 1. My x plus 1's cancel, which is what I was hoping would happen, that something would get simpler. Okay, so now I'm left with x plus 11 over x minus 1. I can't do anything else with that, but I do need to remember that I canceled something. So I need to remember that x cannot be negative 1, because negative 1 plus 1 would be 0, and I can't divide by 0. Okay. 11.7d. This one looks like it might be a little bit tricky, but it's not. Remember that these two things are different. I have x minus 1 and 1 minus x. We can't change the order of subtraction. However, if we're careful, we can. We just have to apply the rules right. So I'm going to leave this one as 5 over x minus 1. And then this, I am going to pull out a negative. Okay? So if I pull out a negative, that makes this x positive, and it makes my 1 negative. Negative times x is negative x, and a negative times negative 1 is a positive 1. Okay, so I've reordered it and I factored it out. If it helps you, you can think of it as writing negative x plus 1 and then factor out the negative 1 if you have a hard time going from the one to the other without this in-between part. Okay, but that's what you're doing. So really, these are like the same denominator, because all this negative means is that this whole fraction is negative. Remember, like if I have 1 over negative 2, that's exactly the same as negative 1 over 2, which is the same as negative a half. Those are all the exact same thing. So this is just a negative. So that means I can put it up here and get rid of it down here. And I just have 5 minus 3 is 2 over x minus 1. And that's it. For some of you, that might be push you over the edge. And for others of you, you might think, oh, that made that a lot simpler. I don't know. Again, please don't be afraid to ask me questions. I love to get your questions. I love to help you. So don't be afraid to ask me when you're stuck. Okay. 11.7e is our last example. I have an x minus 1 in the denominator here. And these don't have denominators, which means their denominator is actually a 1. Okay? So this is going to be my common denominator, x minus 1. In the book, in the example, it has you combine these into one fraction to make it like 2x plus 3 over 1, like this. I'm not going to do that. Well, okay. I'm not going to do it because I don't want it to confuse you, but you can look in the book and see how they did that, and that might be easier for some of you. But I think for others of you, you're going to want to look at them individually as individual fractions and not combine them yet. So I'm going to leave them separate for now. So to get my common denominator, that one is already set. I'm going to do 2x times x minus 1 over x minus 1 plus 3 times x minus 1 over x minus 1. So notice I've multiplied this by x minus 1 over x minus 1, and I multiplied this by x minus 1 over x minus 1. And that's what's giving me my new fractions here, my new rational expressions. So now I have common denominators. So I'm going to combine everything on top. and I'm going to distribute here. Okay, so I have 2x times x and 2x times -1. So I have 2x squared minus 2x. And because this is all being added, I don't need to worry about doing parentheses between these sections because adding, it won't affect my signs. Okay, so then I'll distribute here of 3x minus 3. So then now I'm going to simplify. I'm going to pull out my 2x squared out to the front. I have x minus 2x plus 3x. So x minus 2x is negative x, and negative x plus 3x is 2x. And then I have I'm subtracting 3 here at the end. And that's all over x minus 1. Okay, so x minus 1 can't be factored. My question would be, I wonder if x minus 1 is a factor of this that could cancel. So use your discriminant test if you're not sure. That's always a way to check. Remember, if you do b squared minus 4ac, if it's a perfect square, then you're good. But if it's not, then you can't factor. So that's always something to try. So 2 squared, that's b squared, minus 4 times 2 is a, times -3 is c. So that's 4, I'll write it here, 4 minus, I have 4 times 2 is 8, and 8 times -3 is -24. And because I'm subtracting a negative, that's really like adding 24, which is 28. 28 is not a perfect square. So this can't be factored. Okay, if you were trying to solve it and trying to get like zeros for it, you would use the quadratic equation. But we're not going to do that because that's not what our goal is here. The goal would just be, can I factor it so that I can cancel things? But I don't need to do that here. If I can't factor that, then I'm done with this problem because I'm not trying to solve it. I'm just trying to see if there's anything to be simplified. Okay, so that's our last example. Doing the blues for this assignment. Let's do there are some of them that involve some subtraction that I'm not doing the examples for with you. So when you do the blues, there aren't too many. But when you do the blues, be sure to be paying attention to problems that have subtraction. And you can look at these examples. I'm not going to go through them today. Again, if you have a problem with it, please let me know. But I want to keep our videos shorter if possible so that you have time to work. But like this is an example here where they have a subtraction. And so you just have to remember that if a single term is being subtracted, then everything in that numerator has to be subtracted. So if you look at this example, when I go from this subtracting a 1 over x minus 3, they've made it adding a negative because that's what we do with subtraction. And then here, that negative has to distribute through the x and the 3. Okay, so that's important to remember that when you're subtracting. So change it here at the beginning, and that will make your life a lot easier. It'll be a lot easier to remember to distribute if you just do that from the get-go. So if you don't, then you just have to remember that you're subtracting. Like if you left it as here, if you had a minus and that wasn't there, you were just subtracting x plus 3, you would need to remember that it's minus x and minus 3. They are subtracting both of those things because this is subtraction. So however you want to look at that is fine. Please let me know if you have questions, and I will talk to you guys later. I miss you very, very much. I hope that you are doing well.